In this video, we're going to learn how to factor trinomials of the form ax squared plus bx plus c, where the number a in front of the x squared is a number that is not 1. So first of all, we need to relate what we remembered about factoring polynomials or trinomials using algebra tiles. In order to factor any polynomial using algebra tiles, what you need to do is you need to place all of these tiles in a rectangular shape. And from there, if we measure the width and the length of that rectangle, that gives us what we call the factors. Now right here, if I was to start walking along this side of the rectangle, I would walk x plus 1 plus 2 plus 3. This gives me a length of 2x plus 3, which is right here. And likewise, if I'm to walk along this side of the rectangle, I would walk x plus 1 plus 2 plus 3 plus 4. I would walk a distance of x plus 4. This means that this particular trinomial can be factored into 2x plus 3 times x plus 4. You could also reverse these and put the x plus 4 first if you wanted to. We write this as 2x squared plus 11x plus 12 is equal to 2x plus 3 times x plus 4. Now, what we need to do is review how we did this last time using algebra tiles, or not using algebra tiles. And to do that, we always started with finding the values of a, b, and c. A is the number in front of the x squared, b is the number in front of the x, and c is the number by itself at the end. And what you need to remember is that any number owns the sign in front of it. And that's particularly important if any of these numbers happen to be negative. They own that negative and they need to take it with them when you're writing it down here. In this case, though, a is the number 2, b is the number 11, and c is the number 12. In order to factor this not using algebra tiles, we're going to have to learn a new method that's called decomposition. And in order to do this, the first thing I want to review to help you do this smoothly is how to factor any particular trinomial or polynomial using the GCF. And then I'm going to go back to what we call decomposition in a moment. So, review. We need to review how to find the GCF of a polynomial. And we can use the same method of prime factorization from before, or the somewhat quicker method described to the right. So, if you wish, give this a read and it'll help you factor it without using the factor tree. However, for this example, just to be consistent, I'm going to factor using what we've been doing all along, which is the factor tree. So again, I'm going to break 5x squared down into its prime factors, which are 5 times x. The minus sign goes next. 15 I'm going to break into 5 times 3 times x, then the plus sign, followed by the 10 broken down into 5 times 2. Then what I want you to do is I want you to find what's common in all three groups. So we have a group, and a group. What's in common? Well, there's a 5 in all three groups, and that's all that I see. So you're going to take that number 5 and write it down, and then you're going to write down some brackets following that. Now what goes in the brackets is what's left over. X times x is x squared. The minus sign, then the 3x, then the plus 2. At this point, what I'd like you to do is to remember how we factored this particular trinomial. Now, for the moment, we're actually just going to consider this trinomial as it would stand without the 5 that's hanging out front. How did we do this last time? Well, the first thing we did was we identified what a is, what b is, and what c is. A is 1, b is negative 3, and c is 2. And then we used some blanks. And what the blanks did was they gave us two numbers that multiplied to give us the value of c, and those two numbers added to give us the value of b. Well, what multiplies to give us 2 in the world? 2 and 1, or negative 2 and negative 1. And in this case, because we want our two terms to add to be negative 3, I'm going to call this negative 2 and negative 1, negative 2 and negative 1. And it was really easy to factor this trinomial once we had our blanks because all we did was we wrote down two sets of brackets. And in the first bracket, we put an x. At the beginning of the second bracket, we put an x. After the x in the first bracket, we put the first number, which was -2. And after the x in the second bracket, we put the second number, which was -1. Now what we see is that this trinomial turned into these factors. So I'm going to go over here and I'm going to pull the 5 down because that stays at 5, but I'm going to replace this trinomial with the factors that I found them to be, which is going to be x minus 2, x minus 1. To review this one, let's break this one down into factors using our factor tree. -2 times 2 times x minus 24 is going to be 2 times 12, which is 2 times 6, which is 2 times 3, x. We just sanction this off, and then plus 12, which is plus 2 times 2 times 2 times 3. Nope, sorry, 2 times 2 times 3. What you want to remember about this particular question is that because the first term is negative, we had a rule that told us that our GCF always needed to be negative. So I'm just going to go and write down that minus sign right now so I don't forget it. And then I'm going to go and I'm going to cross off what I see in common between all three groups. Each guy has two 2's. So I'm going to write down 2 2's for my GCF. And that's all I see in common between all three of them. Now what's left? This first term has an x and an x, which is an x squared. At this point, you need to remember that if you are factoring out a negative GCF, what's left in brackets will have its signs flipped. So right now this is a minus sign, but I need to change it to a plus sign. What's left in the second term after that? Well, I have 2 times 3 times x, which is 6x. This plus sign now has to flip because my GCF was minus, and I'm going to have a minus 3. My next step in this question here is to simplify that minus 2 times 2 on the outside, minus 4 x squared plus 6x minus 3. And what I would do right now is I would take this trinomial and I would repeat this process with it. However, when I do that, I'm not going to find two numbers that will multiply to be -3 and add to be 6. So in this particular question, this is the final answer. I can't take it any further. So let's turn the page here. The next example on the top of the page is just factor using the GCF. And again, we're going to break 8 down into 2 times 2 times 2 times x minus 2 times 7x. What do we have in common between each of these groups? I see a 2 and an x. So I'm going to take and I'm going to write down that 2x right here. And in brackets after it, I'm going to put the 2 times the 2, which is going to be 4. The x is left, minus 7. And this is the completed factorization of that question. There's nothing else I can do. All right, new stuff. This is the point where I'm going to show you how to factor a question that is a trinomial, so 3 terms, and the first term is not a 1, it's something else.